Let's solve this GAIM problem together. In Diamond Bowl Me Over, we want to find the number of whole numbers from 1 to 100 that satisfy three conditions. They either have 2 as a digit or are divisible by 2, have 3 as a digit or are divisible by 3, and have 7 as a digit or are divisible by 7. Because the numbers we are looking for satisfy all three conditions, we can go through each of them one at a time and gradually narrow down the pool of numbers. Let's start with the most restrictive condition, the third condition, as this will most effectively narrow down the possible numbers. Why is this the most restrictive condition? The first part, whether a number will have 7 as a digit or not, is going to be the same number of numbers that have 2 or 3 as a digit. However, the number of numbers divisible by 7 is much less than the numbers divisible by 2 or 3, so we know that this is the most restrictive condition. So let's write out all the numbers that satisfy this condition. Numbers that have 7 as a digit are 17, 27, 37, 47, 57, 67, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 87, and 97. The numbers that are divisible by 7 are 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, and 98. Combining our lists, here is going to be all of the numbers that satisfy the third condition. Now let's go through the other conditions. We could write out all the numbers that satisfy each of these conditions, similar to what we just did, and find the numbers that satisfy all three conditions, but this would take a while. A quicker way we could do this is by eliminating numbers that do not satisfy one or more of the conditions. We know that all of the numbers we are looking for are within this set that we just found, otherwise they would not satisfy the third condition. So, from this set, we can eliminate numbers that do not satisfy the other conditions. Let's start with the first condition. We are looking for numbers that don't have 2 as a digit and are not divisible by 2. Notice that if a number has only one of these two qualities, it is still valid, so we are looking for numbers with neither quality. So, we can cross out the following numbers from the list. Now we know that the numbers we are left with satisfy both the first and third conditions. Finally, we want to eliminate numbers that do not satisfy the second condition, those that neither have 3 as a digit nor are divisible by 3. Crossing out these numbers, we are left with 21, 27, 42, 72, 78, and 84, which satisfy all three conditions. Thus, our final answer is 6 numbers.